Okay, so today we're working on counterexamples. So let's start with conditional statements. Conditional statements are if-then statements that we've been working on. So the first line of this page in your interactive student notebook says, a conditional statement can have a truth value of true, meaning it could be something that is true, or it could be false. Obviously, if I'm giving you a definition, it's going to be true. But just a general statement written as if something happens, then this is true, that doesn't have to be true every time. So to show that a conditional statement is true, you have to show that every time the hypothesis is true, the conclusion is also true. So it's actually more difficult to prove that an if-then statement is true because you have to prove it for every time. But to show a conditional statement is false, you need to only find one counterexample. So you just have to find one example that doesn't work. So it's called a counterexample, for which the hypothesis is true, but the conclusion is false. So let's look at a few examples. So it says you can show that conditional statements are false by finding a counterexample. So the hypothesis says if it is not a weekday, so we need that to be true. So we need whatever our counterexample is to be true that it is not a weekday. It says then it is Saturday. So how could we prove that wrong? That it could be that it is not a weekday, but it doesn't necessarily mean it's just Saturday. So my counterexample is it could be Sunday. Still part of the weekend, so it's not a weekday, but it is not Saturday. Let's do the next one. If you live in a country that borders the United States, then you live in Canada. So we want the hypothesis to be true. You have to live in a country that borders the United States. That needs to hold true. So what's another example that would stay true to the fact that it borders the U.S., but not be Canada? Okay, you could live in Mexico. So it would be true for the hypothesis that it borders the US, but it would prove that, oh, it's not just Canada as an option. So this is called, when you have a converse of a statement that's not true, it's called a fallacy. So we're studying fallacies. And so committing a fallacy would mean when you just assume something's automatically true, but it's actually not. So that's not a super important part of this. The main key is understanding what a counterexample is and how to find it. All right, let's do some practice. So find a counterexample to show that a conjecture is false. So it says the value of x squared is always greater than the value of x. So when that's false is, for example, if you had x and maybe x is, I don't know, maybe -4. Well, x squared is going to be -4 squared. And so -4 squared is 16. Well, that wasn't a counterexample because it said the value of x squared is always greater than the value of x. Well, 16 is greater than the value of x, which was -4. So that's not a good example. So sometimes you're trying to find one and you just have to try a few different things until you get one. So like I tried a negative number. If I tried a positive number, like say 3, well, if x was 3, then x squared would be 9. So x squared is bigger than x. That didn't work. So I tried a positive and I tried a negative. Why don't I try a decimal? So I'm actually going to try, how about, let's see here. I don't need that there. How about 0.5? So if x was 0.5, that's half. Then 0.5 squared, if we did that, that would be 0.25. So that would be a counterexample because if x was 1/2, then x squared would be 0.25, which is 1/4. And in this case, x squared would not be greater than the value of x. So that's a counterexample that works. Okay, let's try this one. The sum of two numbers is always more than the greater number. So for example, if you had 1 and 4, well, 1 plus 4 is 5, and the sum is bigger, 5 is bigger than the biggest of the two numbers. Okay, so that's not a good example. Let's go ahead and let's try some negative numbers. What if we did -2 and -3? So the greater of the two numbers is -2. That's farther up on the number line. So if you add them, -2 plus -3 is -5. So check, is the sum of the two numbers more than the greater number, which is -2? No, -5 is actually smaller than -2. So using -2 and -3 as our numbers will show a counterexample. Okay, here's one that isn't really with math, it's just using the counterexample. So anyone who lives in Augusta must live in Maine. What would be a counterexample to this one? All right, so you could live in Augusta, but the Augusta that is in Kansas, just down Kellogg from us. So that would be a counterexample. All right, what about D? A rectangle that has an area of 16 square inches must have side lengths of 2 inches by 8 inches, because 2 times 8 is 16. What is a counterexample that would work for that? Okay, so it could be one that is 4 by 4 inches, and although that's a square is also technically a rectangle, so that would work. Another could be a square that is, a rectangle that is 1 inch by 16 inch, because its area would still be 1 times 16, which would be 16 square inches. So either of these two examples right here would be good counterexamples. So a counterexample is just when you need one example that holds the hypothesis true. So what you start with, the hypothesis it fits with, but it proves the conclusion is wrong. So it's really easy to prove a statement's wrong. It's much harder to prove that it's true for everything.